Hey folks, okay, lab one time. So I'm assuming that by this point you've already watched the intro for the labs in general. So if you haven't seen that, go through that one first because that does introduce kind of the sequence of steps that we're going to be going through in the labs. And it also introduces the language that we're going to be developing a syntax checker slash compiler for. So that was the first thing I would recommend you go off and do. When you're going through, again, for the labs, we're going to be using Git for distribution and collection. So if you're rusty on the Git processes, make sure you go through that. And you are going to need to use lex and yacc. So it's going to be important to go through and understand the video material on those as you get into working with the lex and yacc files for this particular lab. So if you back up and hit the recap, again, it's got the theory sections on grammars and languages that we'll be going through in the lecture half of the week after the 7th. And then the material on lex and yacc in particular, where we'll go through the use of the language or the use of those tools, the syntax that you'll need, and that kind of thing. So you will need to kind of review those before you can get much done in the lab itself. Alrighty. So, again, what we're doing in the labs is developing first a syntax checker and then eventually a translator for our Wanderful language. And so what you're doing in lab 1 is essentially just going through and developing an error checker to make sure that the structural syntax of the language is correct. So let me ditch my talking head here. So we want to go through and make sure that our syntax checker, our lab 1 executable that we're going to be creating, can actually recognize all the valid constructs in the language. So what I've done is in your lab 1 repository that you'll be forking and cloning, there are skeletal versions of a .lex and a .yacc and a makefile to use them to build the lab 1 executable. And so essentially what will happen is you're going to finish lab1.lex and finish lab1.yacc. Then you're going to run make to build a lab 1 executable. And then your executable is going to be able to take Wanderful programs as standard input and check them for validity. So you'll be able to run your ./lab1 and feed in the program that you want to test, and it will either compile okay or it'll generate an error message. Now, in the skeletal version, the lex and yacc files think that the valid syntax for a Wanderful program is just start, a number, and finish, and that's it, which is, of course, not valid in the first place, and way more is needed. So it's just to give you kind of the form of the lex and yacc files and get you started. And you're going to be going through and expanding the rules so it correctly recognizes the language. A couple of things about it. The skeletal version also keeps track of what row and column you're on as it's reading through the source code, so that when it does give an error message, it can tell you, well, I got to row 17, column 7, and then I couldn't figure out what was going on, essentially. So maybe we'll just quickly take a look at the repository side of things, and we can see that in action a little bit. So when you fork and clone your repository, you're going to find these 4 files, lab1.lex, lab1.yacc, a makefile, and then just a sample Wanderful program. So that test.wan at the moment just has the start, an integer, and finish in it. Again, the makefile will build the lex and yacc and create an executable for you. It creates a whole bunch of other stuff as well, but it's the lab 1 executable that we're interested in. So if I just try a make, it'll go through and run all this. And the one that we're interested in, so if you have a look now, you'll see that it created a debuggable executable, but the lab 1 executable is the one we're interested in, and it creates a couple of other intermediate files, the y.tab, y.tab, the lab1.yacc, or pardon me, lex.yy.c that you can browse through if you want to, but they're really not what we're interested in. So in theory, now if I run my lab 1, if if I run my lab1 executable and take that test file as input, it goes through, compilation begins, compilation complete, no error messages, so it thinks that that program is correct. If I was to put something in test.1, so if I don't know, I'll throw something in here that it shouldn't think is valid. And so if I try that again, it goes through and says, something's wrong, right? You've got garbage in there someplace. So unknown character, whatever. It's going to go through and give me some kind of error message. So I know that that input program was somehow not valid Wanderful. So if you're looking in the two files that you're going to be editing, so in the lex file, again, you're going to need to go through the videos that bring you up to speed on the lex syntax, but it's got these three parts to it. It's got a set of declarations for things like the regular expressions to describe what a number looks like, what a name looks like. It's got the C code setup that we're going to have to rely on. So in this one, it declares the functions that we're going to use, does the necessary hash includes, sets up the row and column global variables. And then it's got the token rules that it or the tokens that it recognizes right now. So right now, it recognizes a number if it's one or more digits. So it's got a regular expression for recognizing a number. And in here, it's going through and keeping track of, again, hopefully you've gone through the lex video, but it's taking a look at how many characters there were in the number, and saying, okay, well, if I read in the number 356, that had 3 digits in it, so I'm now on column 3, or I've now advanced 3 columns. Similarly, if we see the keyword start, I'm going to recognize that as the start token. If I see the keyword finish, I'm going to recognize that as the finish token. And I'm going to update the fact that, well, I've read in 5 characters, so I've moved along 5 columns, or I've read in 6 characters, so I've moved along 5 columns. It will skip over white space. So if it sees a space, a tab, a form feed, a vertical feed, then it just says, okay, well, just treat that as a single column, single character if you like, which isn't quite accurate, but that's okay. And if I see a new line, then if I've moved to the start of a new line, then my row number goes up and my column goes back to 0. So there's just a whole bunch of rules in here on what to do with the different types of characters and different types of tokens it might see, and identifying, again, what token type is associated with that. And anything else, anything it sees that isn't one of those things is an error. So this actually goes through and sets up the beastie to display an error message. And then down at the bottom, we've got the implementations of the functions that were referred to in C++ code up at the top. In the lab1.yacc file, we see the grammar rules for the language. So again, there's the setup for the C side of things. We specify what token represents the start, or what construct represents the top level component of a program. We specify what data types, and we haven't really gotten into that yet. You can stick with that'll become more interesting when we get into the semantic checking. We identify each of the tokens that are supported so far. So as you start expanding your lab1 code to handle more different kinds of tokens, you're going to have to add the rules for each of them in the .lex file, and you're going to have to add them to this list. And then for each of the components that are used that have got a data type associated with them, we're going to specify the type. Again, this is going to become important when we get into the semantic checking starting with lab 2. We then go through, and then we have all of the grammar rules for our language. So for instance, if we decided that our grammar said a program component could be the keyword start followed by a statement followed by the finish keyword, this is the sort of syntax we'll use. The component, a colon, what it's made up of, and then a semicolon to end it. So at the moment, this thinks a complete program has a start, a statement, and a finish, and then a rule for statements where it says, okay, well, a statement is a number, and a number is one of the tokens that we defined and that was described in the .lex file. So we've got the sort of preamble up top, we've got our set of grammar rules, and then at the bottom, we actually have the main routine for our lab1 program, and at the moment it just lets us know that it's starting to compile. It calls yylval, which actually carries out the automated checking based on all of these grammar rules, and then tells us when it's finished. And tells us, tells us when it's finished. Let's see, that's pretty much the rundown of the idea. You're going to be expanding these, obviously, to handle all of the different grammar rules, but that comes back to making sure you've got a decent understanding of how the lex files work and how the yacc files work. So I'll be getting you to go through those videos, and we'll be talking about them in the Zoom sessions for the lab. All right, that's where I will leave that. Oh, actually, no, not quite. I did also want to talk a little bit about the testing side of things. So obviously, when I go through and test your lab1s, I'm going to be going through, I'll run make on it to compile it, and then I'll be trying your lab1s against a whole bunch of valid Wanderful programs and a whole bunch of invalid ones that have got different forms of syntax error in them. So it would be a good idea now if you start developing an entire suite of test cases that you can use for your Wanderful programs. And this would be a good point to go back to your bash and whatnot, or whatever scripting language you prefer, and just write up a little tool that will automatically run your lab1 executable against all of your different test cases, just to kind of automate the testing for you so you can start checking. You can play with your .lex and .yacc files, compile it, and then see if it correctly handles all of the different test cases you put together. Because it is really easy when you're modifying your lexes and yaccs to put in code to recognize one kind of syntax error, to handle some kind of syntax rule, and in so doing you break something else. So getting into the automated testing is probably a good thought about this point. All right. Usually, for the labs and the projects, everything has to be your own work, the usual idea. But for the test cases, if you come up with interesting, wonderful test programs, right, interesting source code programs to test out your syntax checker, your lab1 executable in this case, then I have no objections if you actually share those with each other. So between the lot of you, you can come up with a whole slew of interesting test cases that you can test your various executables against. All right, that's where I will leave it for this time around.